Yeah, the title is already clear, so let's one step ahead. Who I am. Gary was kind enough to introduce me extensively. So what is it talk about? It's about two things, and I think people forget about it. I always see that there are two camps, like the developers and the security people, but actually there are about two very important things. One is code. What is software? We have to realize that these days, and I always jokingly say the 27-year-old senior full stack developer, she or he will consider everything to be code that she or he can commit to a source code repository or GitLab or Hub, whatever you have. That will be considered as code. So the other thing is responsibilities, another keyword in my talk, and it's about who is responsible for the code. Because isn't it really weird that security becomes kind of responsible for the security of the code what you're doing? And as I always say, software security people, you don't do security. When you look at it, you don't do security. When you look at a guard at a museum or art exposure, they are doing security because they're securing the artifacts they are protecting, right? Like a bodyguard. He has very clear security job. But do we protect anything? We will. No, we don't. You hack, you show vulnerabilities, but you're not securing. But I'm already going ahead of my presentation. So let's take a step back and say, what does coding actually mean? What has changed? And to know what to do today and why you're doing it, it always helps to know why you do something. Let's have a step back on how it comes we do the things. So first of all, software development started early last century, right? And the first developers we know were women, were not males, because we were fighting. They were fighting. Luckily, I had to fight. So the males were fighting, and women wrote the first code. And not much changed because you need some kind of requirements. Then you need some kind of design. I know, yes, DevOps, we don't have architecture, but you still have it, whatever you call it. And then we do implementation, we do verification, and then it has to be maintained, right? There's nothing changed. And even in such a young area of job, you cannot expect much to change. What it has to be structured, because when you repeat a process, it has to be structured so you can measure success and quality, because that's the difference. When you did a coding in university or your hobby project, it's all nice, but now you are, the developers are enterprise developers, right? You can do it for business. You're a professional coder, you need professional quality code. So the first process, or not the first one, but the most known, and I think for good and bad, has been waterfall, where we cascaded the requirements of the artifacts of the different steps down to the final maintenance as documentation, right? When you ever had a question in the steps below design, you couldn't get back out because there was no feedback loop. And yes, I know that later on they build them in. I have been a development contractor, so when you came back like, oh, who wrote the design and requirements because I have a question, they were either not available because they were from our team, and or they had also the whole thing was dissolved, right? So in years-long projects, we developed code the customer never wanted. It's kind of the, I think it's called telephone game, when you whisper a word from the first a person's ear and they whisper from one to the next, in the end a different word comes out, right? The same we did that. And don't forget about maintaining all the source code. So what was next was the big relief of the overhead. It was extreme programming. And that was really cool because now we had a circle. We went on sprints, and everything we do now is DevOps or Agile, whatever you want to call it, has an origin in extreme programming. Because we said just to purpose, build just to purpose, build just in time. But when you start, build the more complex things first. Don't start with the easy things. Start with the hard things, because then you know where you will have problems. The next thing is also then you had this user values and user details, right? Simple design and even the refactoring, right? The developers were in charge. And actually, developers and testers became friends because now we had peer programming. So we looked together behind one keyboard, and I always hated it when somebody touched my keyboard, but now you together made the software better. There was two problems with this. One problem is business was not involved. And the second, and I don't know if it's maybe the bigger or lesser problem, was that Actually, operations were not involved. So the testers and developers became friends. That went some software, and they released it to the maintenance, to the ops guys, and they were like, what do we get now? Because they were not involved. And I said, the business was involved. So now we have the agile sprint, and I said, okay, time and money is bound, but functionality is flexible. But you couldn't sell that to business because they didn't understand. The next logical step was then to exchange program. DevOps was actually over the side of agileness, CI/CD, and then to come to DevOps. And it's very important to highlight the focus on agile being on the process, because now we have a standardized process, agileness. We have other flexiness, but we have to be highlighting on changes. We have accelerated delivery. Whereby CI/CD now, because we did some things repeatedly from the same program, we did it over and over again. Like, hey, I don't do it more than once, I do it twice, I do it more than that. I can automate it. So software-defined life cycles, because highlighting the tools and emphasis on automation, remove the human failure. And the last step then, when you come together, and I know that people use it interchangeably, but it should not, is the DevOps part. Now you focus on the culture, and what's very important, you highlight on the roles, because who is responsible, and on the emphasis on responsiveness, because everything that is true today can be changed tomorrow. The technology can be also security, and I will come back to that later on. So with DevSecOps, why did you say DevOps and not DevSecOps? And that's very interesting. Why is there a SecOps? And I think, and I was one of those who didn't believe in part. I don't remember many years back, Dennis Cruz said, make security transparent for developers. And I was like, oh no, they have to be aware of it. You have to put a face on it, you have to make them learn. But actually, I have to admit, Dennis was right, but he was many years ahead of mine. So he said, and the same is here with DevOps, yes, we call it DevSecOps, just to put an emphasis on the security. But it's not there to be there, because people should do the right work. And I think that's very important. We as security people say, oh, this is a high-risk application, now we need more security. No. The standard way how we write software should be the secure way. What is the difference is the amount of verification it is secure depending on the criticality of the application, right? And I think this is also wrong, because there's a way how we write code. There's a way how we connect to the database. And we know, everybody in the security and the most developers know, yes, you should not do string calculations to create a query string. But then what should you do? And you should always do it the right way, right? And this way we have frameworks and libraries. But let's go back, what is DevSecOps? So one is the tools, and we have various tools that we can use. And the first tool, I said, when you can use tools, and I said, before you write one line of code, because you have to set it up first, right? And this stage is all those configuration files that are seen as code. So the moment you have your build configuration, with your build pipeline, you have your dependencies in there already. We know which server you're talking to. You can use static application security testing. And that's not one way we do it. It's not just by commit or just by nightly build. There must be a graduation on testing. Because when I always compared when I was a developer, software development, by writing a story, writing a book. When you write a book, you don't wait the whole book to be finished before you take care of the spelling errors, right? Your favorite text editor has functionalities, file-based or even line-based, sentence-based. Do I do anything wrong with the grammar? Do I have my word, have I spelling mistakes? We have this with compiler errors for your feedback from the IDE. And do we have any grammar mistakes? And that's already on file level base. We can look, are there any untrusted or unsecure functions used? So on the IDE, it's not a full scan, it's just high level, but it's quick feedback as we write on a file level security, the first level. And then maybe when you check it in, when you commit it, you have this coffee break check, right? You check it in, I get some coffee, I come back, and I want to have some results. It's just another level on commit level scan, where you do not a full thing, but it's just a kind of incremental scan, a small scan, and see is anything wrong in the context I just submitted. And then, of course, when it's on build, then you have the more in-depth, maybe days taking scans, depending on your complexity of your source code. But so there's no one way to do it, it's several ways. So that's only the static application security testing. The next step, of course, you can already create is the software composition analysis. It becomes more and more important as it became always top 10, I think A9 it was in 2017, when they said the usage of known unsecure dependency in libraries, right? We know these days we write only 10 to 15, I think, on max of the source code ourselves, but the source code comes from somewhere. And actually what? You know what? Other people wrote other software. Even your Java or the .NET framework, your PHP framework has been written by people, and therefore there might be errors in there. The software composition analysis helps you to find them. And yes, of course, that always has a really good tool. It's the lowest level, like, hey, is there anything known against this version in the NVD, the National Vulnerability Database? So it's just something, you don't have to think, do I have to do it? No, just do it because it's there, and that's what about tools. That's why you integrate tools in your pipeline, and that's the most important thing of the tools, to be integratable. But then it doesn't finish there. The next step is the dynamic testing, because we can look at all the source code. Because I said, everything that is in your context is source code. It's your dependencies, it's your build files, it's your configuration files on your Kubernetes or on the container. Everything can be seen as source code. So is there any secret in there? But then we only know that on a static way. That means that on the dynamic vulnerability, it has to do predictions. And yeah, we know everything's easy to predict except the future. So you don't know how it will respond when it's in the dynamic runtime. So that's why you have Dast for. These days I hear people, forget about SARS and Dast. IS is the holy grail. But really? Really? Because in Dast, we see everything that we can think about in a scale. And the same for IS, because you only can use IS in every, of course, security testing is based on quality. When you have tests in place, when you have a complete test set and a comprehensive test set. And we are humans, we never have everything full comprehensive, right? So SARS gives you the whole naked truth about your software, but then is it relevant in the dynamic context where the dynamic looks from the outside? Can we figure out any functionality that has to be exploited? And then IS is another level of increasing security where you have your tests running and you're monitoring what is happening on the end. You never should ask yourself, you do one or the other. You should have a holistic, most holistic application. Of course, you don't do it full blown for every application when you do it by hand. But as I said, there is not, the one application has to be secure, the other hasn't. It's about, we have to write secure software. The level of verification changed. But now verification, when you automate it, it becomes cheap, and therefore, why should I do it? It's already in place. It's just to hook up the tools. So that's it. And that's actually where comes our security champion, right? Everybody has highlighting a role, so somebody must be responsible for security, and in a team, it must be the security champion. But there have been many mistakes made, and I think we still do mistakes on when we address the functionality or the responsibility of a security champion. But first, I want to highlight some points that go wrong when we talk about DevSecOps. And I think most of those are caused by the security people. First of all, the number of FTE resources, right? When you need someone dedicated, because these days I see it's not developed buying those tools. It's security. Security is actually having the money and they're buying the tools to verify the security of that what the developer builds. So the security needs more FTE to maintain it. And then, of course, we have more complexity. So we add complexity, we the security people, to them, the developers, work. And they don't see the benefits. They only see when they get hit by the security state. Isn't that weird? And then the security people, they get KPIs by finding more vulnerabilities. So they're offloading responsibility to security developers. Say, oh, you have to integrate this. And then they get hit by number of vulnerabilities because that's where they find it. And then all the manual qualification you have to do over again because you do it like once a half year, once a year, right? And then what's about the third-party software? You have another tool vendor you have to maintain. And of course, a tool per functionality and technology, it's cumbersome. So let's see how then in practice it goes wrong. What I saw in my long time as a consultant is first as every role is there, right? And we have DevOps, but doesn't anything change? No, because when we said it's a team responsible in DevOps. DevOps has a really, really important thing. It's a big change. It now has a team from cradle to grave responsibility of a project. It's not that in the past, when you had a project team that either creates a new application or adds new functionality to an existing application. Now we have a smaller team who has one or more applications they maintain. They know it from inside out, and that's their work, right? From cradle to grave until this project ceases to exist. But they are one team, and the security is outside the team. And I have heard, and I really get so tired of it, so many talks, even today in this conference, when we say the developers. If that's, as long as they're a they and them and us, it never will be really a team effort. So that's so on that. So business has money, they assign some work, so it has to be something has to be done. So the dev team, DevOps team builds and deploys this cool new feature or extension. Security finds out about it by accident, and they hack it, break it, and then they blame, oops, my security guy is gone. They blame it by the security report and requirements that dev team never heard about because it's maintained by the security, right? So we go with this new report, say, hey, dear business, look, they haven't been compliant with our security policies. You have to stop this. But the business can see only one thing. They have to accept the risk because, wait a minute, from the minister to know in the past, security became the minister's flow. So now suddenly the dev team has to wait 3 weeks, a month, 2 months for security results to come in. By that time, the business cannot wait 3 weeks. So development becomes agile and security is leaking behind. Barely can keep up. So, and then of course, hey, we have our security champion. Let him do the validation because we security, we are much important, we are much too bright. Let the development team solve it. So that's what I meant, shifting off responsibilities to the security champion. Good luck. If you want to discourage anybody, is by uploading only the shit jobs, sorry for my French, of your job. That will not work. But this is how it should not be done. And let's look at the bright side now. Yeah, we have some time left. Let's see the positive thing. So what you need to solve is you need one unified dashboard. When we talk about the same thing, we need one view of the truth. And it should have like more capabilities, kind of a risk management abilities. And it should be a kind of a software asset management because you need everything in there. You should have to add my software integration, automation, and we should do the KPIs for both teams, developer and security, for time to fix. So the quicker they are, the easier it is. We should have a vulnerability management that looks at trends because I don't care if my application has 1 or 2 SQL injections. There is something wrong. So we have to change it by not by patching this problem, so fixing the symptoms, but have to have architectural proven solutions, right? So now we have the same thing, but we have to make it one team. That means one central dashboard that we can benefit from. Oops, there's something went wrong with the slides. So first thing is, who owns this application? Who owns this one dashboard? As I said, security has the money, so they own it, they maintain it, but they have no ability to maintain and run an application. It's the developer team who is they're living and then understanding to maintain an application. So they should do it. Yes, the security should be the sponsor, but not the owner of the application, right? They maintain it and operate it. They build in, do the DevOps thing. So therefore, that's where it comes to tribe of the security champions, right? In DevOps, we have our tribes, or how you want to call it, and the tribe security champions should maintain the vulnerability dashboard. And they are those who make sure that it's automation, not the security put it up on them. We give the tools to them and say, let's do it. You should do it, right? It's your tool. It's not our tool. We are the sponsor of it. The next thing is then, because it's there, it's one unified dashboard, we put the security requirements there for the C, and it should not be this high level standard. You should not have SQL checks. No, we can have, for example, the ASVS based on the type application. It's a front-end Java application. It's a back-end .NET application. It's an SQL. It's whatever. We can have a subset of our requirements default automated. For example, OWASP projects the security red, the requirement automation tool, is helping you in this. So one dashboard with one requirement set depending on application. So when the security champion creates this project, he can say, okay, it's a backend application using Java, has a .NET, has a SQL injection, SQL database, and we have no front end, or we have whatever. Yeah. So to the point requirements, readable. Then the security champions are responsible for integrating all those tools in it, because it's already default, it's their ownership, so they will make sure they can do it, and they can exchange on how to do it better. Yeah, because you repeat it, it comes better. And then, of course, the security team has to do can now focus on that what they are good in, using the human brain and intellect to do the multi-level functional vulnerabilities. Because don't forget it, a tool only can find technical errors, no flaws, because the tool will always assume it's built as it should be. So what is the benefit? The benefit is the way the team has early feedback. They have ownership, control, and get a feedback. And the role changes from security, from becoming the one who bashes with the security stick, is becoming a mentor and monitor. So you monitor the progress of the teams, and you're mentoring them. That means when you see, for example, a certain race in the trends of tab-napping, you can ask those security champions who have this problem, like, hey guys, what changed in your project that we have to suddenly disgrace in numbers? They come together. Maybe it was an update on the front end template engine, right? So they can look what was the problem, what caused this race, and they can then spread the knowledge over the teams and can prevent it. That is really much better to work on trends than making total numbers. That also means that now your security, the CISO will be happy, because he can say, we don't need this annual training. It's a waste of time. How many times I've seen this, that you do a PHP-based security training for Java developers or for Python developers doing Java training. It will not help. Just waste 1 week of time. What you want to have is like, hey, there's a security issue coming up, and you do on-the-case training. But you also can do, for OWASP SKF, hey, you do functionality in your sprint, and it's maybe also something for this dashboard. You create a file upload, and then you have certain vulnerabilities, and you get a training to the point that interests you, or training to the functionality you're developing, right? So we have much more training, but it spends less time, because it's not an offsite 1 week training, but it's a instant, maybe 15 minutes, half an hour training to what you need, because you don't remember when you learn something about stuff you don't need. And of course, our business will be good, because the business is restored. Yeah, that means that you are now in desert of have a holistic view of application. It's ownership by the developer. And I hear many times developers don't want to write secure code. This is bullshit. I don't believe it. And of course, it's you make them responsible. And if they're good, of course, craftsmen, but you need craftsmanship. And craftsmanship cares about what he created, he or she. So what you need is craftsmanship. And craftsmanship, you have the responsibility, but you also have to give them the ability. And when you give them the tools and you see the team's good, you let the reins go a bit, because you know they're trustworthy. And those who are less to trust, you pull the reins on. It's like, hey guys, this is not working. I will have a big eye to you. So this is the game you have to. But the first thing is you have to be part of them, and you have to be integrated. So one thing we left out so far, it's on the right side, is the responsiveness. I see everybody looks at the inside, because software development, so we need the life cycle. But when we forget, now with DevOps, they are responsible of the whole life cycle application. So also the tools, the OSINT tools, for example, we have to verify what is under production. This is another chance where our security guy is the mentor and the application, security champion has to be then those who operated and be in the connection, right? And of course, for everything, the connection should be, yes, this one dashboard. I really hope it will come out. I have seen really good tools also coming up with integrating the risk, but we still want to, the most software, and I worked for different houses. When you are a company, it's not only software you build, but it's also the software you run. When you're more than one company, we have the employment graduations applications. You have your tax, you have your HR. There's all external software you want to test. And your dashboard has to be a holistic place of your software assessment. software portfolio you have, because whenever something comes up from responsible disclosure to an OSINT application alerts you, you need to know where it is it still running, and who is responsible to fix it. We all have seen that when the business, you ask them, hey, what is your internet presence? Send me a list of your applications, and say you get 100 applications, 30 most likely don't exist anymore, and 40 who are already up and running are not on the list, right? So you need one dashboard who is live and up to date, and you need to know responsibility. So change responsibility, our tools should be developer tools, given to the developers. They have to operate it. That keeps you the head off. You don't have to do stuff you're not good in. For example, maintain a dashboard, and you can focus on the real important stuff. And one thing will shift in our time as well. I will not want to see any tool monkeys anymore in this area the next 5 years, because every tool we can automate. I want you as security people to use your brains to mentor and become friends with developers. I think my time is up. Thanks for listening to me. I hope it helps to give you some insights. Gary, how are you doing?